All right. Hi, everyone. Super excited to welcome you all to the last session of the MLOps Salon. This is our panel. We cap off every MLOps Salon with a panel. Today, we have three amazing guests who will be talking about building AI-enabled products in their respective organizations. I'll allow them to introduce themselves in just a moment, but we have Meenakshi, who you've heard from before already. We have Lukas as well. He's been a speaker. And then we have someone from the Verta team, which is Conrado, our CTO. So to kick it off, Meenakshi would love to learn a bit more about you and how you use ML in your organization.
Absolutely. So, hello everyone. Thank you for having me. I'm a technical product manager with Wayfair. Wayfair basically is an e-commerce platform selling home goods to our users and making that user experience smoother and faster and all those nice things. Um, my team, ML Platforms, is basically responsible for empowering our data scientists, providing them right tools, and in a scalable and robust fashion so that they can do ML development e- and deliver the basically the um, data science models to the business. Um, a little bit background about myself. I have an interesting background. I've trained in software engineering. Then I worked on different domains, bioinformatics. I did some research in that area during my college. And then I moved into IoT platform where I was, in the team developing software as a platform, helping with IoT, gather data for IoT devices. And I ended up now at Wayfair as a product manager. So I did the transition because I was very curious and I wanted to develop myself into being closer to product and users and help these amazing products. So that's me.
Thank you so much, Meenakshi. Over to you, Lukas.
Hi everyone. Thanks for this great opportunity. So my name is Lucas. I'm Gubo. I'm from. I'm sorry. I'm working for a non-profit organization called Virufy, and our main idea is to allow all people to have across all the nations to have access to fast and affordable access to the healthcare. So we're using this technology to do so. We, with the help of kind of cutting edge, we're trying to create and predict um, kind of code based on the cough. So we're using audio files from the phone, and on this we build an AI platform to predict coughs and likelihood of a COVID. So yeah, I'm also coming from a software kind of engineering background. I was writing a lot of Java codes before, but I kind of transitioned to more project management to kind of understand and create products like this at Verify.
Wonderful. Thanks for joining. Conrado, if you want to give a quick intro.
Hello, folks. I'm Conrado, CTO here at Verta. And before I was at Twitter, one of the leads for the Cortex platform, where we're trying to make everybody more efficient and bring the next generation of machine learning applications inside Twitter. From applying deep learning to all different parts of the stack, resolving issues live, in batch, and just making sure that data scientists were empowered inside Twitter. Then I was at NVIDIA, where I was doing a similar kind of work, but for the self-driving car. So making sure that the data scientists were able to really get their best models out as fast as possible, and with a big focus on CI/CD, because autonomous driving, you need a good level of safety, and we want to make sure those models were the highest quality. I do come from a background of engineering, but also of academia. So I started on robotics. Then I was like, oh, machine learning, it's extremely interesting. Let me do more of that. I did a master's on autonomous vehicles and a PhD on optimization and approximation. use machine learning. So yeah, I'm excited to be here.
Wonderful. We have a super accomplished technical panel today, so I'm excited to see how the different experiences have translated. So let me open it up with maybe an essential or fundamental question. What is different in your experience about building AI-enabled products versus building regular products in your respective organizations? And Meenakshi, if you want to start it, and
Sure.
we'll try different orders as we go
All
along.
right. Yeah, happy to. So AI, building AI-enabled products, I think a lot of principles are common. For example, as a product, like product discovery, engaging with users, and being owner of your roadmap and product strategy, I think all of that remains the same. Uh, what is different is the stakeholder group might vary. For example, I work internally. We are owner of the platforms within the company, ML platforms for the company. So our stakeholders are not just data scientists. We need to think a little bit more broadly because we need to also engage with other platform teams. We need the data is an important aspect of machine learning pipeline. So you need to also engage with influence in some aspect, data engineering, um, and so that's one aspect. Stakeholders may vary. Secondly, I think of comparing it with software engineering product manager versus ML product manager. Um, your you think of your users; they're a little bit less technical than a typical software engineer. So, you know, product managers often talk about ease of use and simplicity and all of that, but more so here because they are very research oriented. They might not even know GitHub and these simple things. So just be cognizant of that. Um, also. As a product manager, data, right? When you are developing software platform, data is not as much maybe critical part or integrated as compared to machine learning products. At every phase, you need to think of how data is being consumed from the previous step and how it's being translated and transferred to the next step. I think those would be my pointers.
Wonderful. Lukas, would you want to add something to that?
Yeah, I can speak mainly only from the product AI enabled because we are trying to create a unique product for pretty much patients and everybody in the whole world. So creating a AI enabled product is mainly based on the data. So first we started and having mainly the data to build the product on itself. So that's mainly the important part, to build on top of the data and then have a AI instead of going the other way around. Let me have an AI to fix the problem. So we started a different route, and I think that's the most important kind of section in this.
Yeah, and I think like both of you nailed on the head. The aspect of data, it is a critical piece because what I used to tell people when I used to teach machine learning, it is the data that you're receiving today is the data that you like to have received like days ago, so that you could train a model on that data and make sure that the model takes that into account. But unless we figure out time travel, that's not going to happen. So for us to be able to think about the data and reason the data from the moment that it was collected all the way through the training, like data preparation and training and validation, and now the production system, how do these things relate? And like, has something changed in between? What is the relationship between the data on the two extremes so that we can reason about correctness? Software engineering, you just set down, like write an API saying, this value is a string, and it's always going to be a string. But when it comes to real data, like things happen.
Things happen. Like,
Exactly. Speaking of things happen, right? When something happens in software, we have a process, usually kind of agile process, to go figure out what's not working and then adapt to it. What has agile meant for your teams that are working in this new domain? Can you just Are the existing constructs enough? Have you had to develop new ones?
I can talk to it. So Agile is good and also bad, I would say, in the AI, because these principles pretty much apply to the data science in generally, but usually they have to be adapted in some way that are extremely kind of iterative, because data science you can just go over, make more iteration, create small POCs, then you go over and over again, make them nice and finished. So yes, they are supposed to be iterative as well, but they are often considered not so iterative enough for us as a data scientist or the team. In other words, agile is not agile enough. Of course, the extremely iterative nature of AI and machine learning project is that models are actually applications, and that are automatically generated by the machines at the end. It's at some extension depends what kind of tools you are using. Um, so they crank out of many model iterations and experiments in a short time span than human could ever do. So agile is good, but at the end again, the development starts from a data perspective, and data projects itself have not always fit in an agile approach, because the data process is cleaning and doing all these ETL stuff. It's very slow and steady. So then at the end you would go to a kind of waterfall approach with the data. So at the beginning you might have agile through model development, but it comes down to a data which is more waterfall approach. So it's a little bit of both, kind of.
That's
what I would say.
fascinating.
Yeah.
Has that been your experience too for the rest of the folks?
I'm afraid I have a little bit, but because again we are platforms provider, so we are like our obviously our users are solving very niche, very varied set of problems and driving businesses in different steps. Um, but as platforms provider, we focus on providing more generic to the in the beginning solutions that can serve, like follow the 80-20% rule, and um, we definitely iterate a lot. We engage our users a lot when we are doing whether it's user interviews through the discovery process, or let's say we have a POC, we pilot with some select users. That has been very helpful. Again, it's a very diverse set of needs, so we are kind of trying to refine our requirements while working with different kind of user groups.
Yeah, I think one of the uh, big challenges that people come with, like when he talks about agile, is you can only move as fast as your organization or your problem. So when you're building machine learning products, there is aspects of I can train my model and like iterate on it, but maybe it's gonna take me a month to run an A/B test and know if it's gonna be good. So even though I'm running like a very fast process in my team to create a new model, the result is not necessarily fast to get. And then a month later, you need to go remember the context of what you're doing
Mm-hmm.
and like figure out, okay, is this thing worth? Do I need to adjust on that or not? And I think that's the big disconnect that comes with like the agile methodology today is it takes so much time for you to see the result compared to like software engineering. You build something, you deploy into production within like a couple of days at most, and like now you have that providing value directly. Actually, you need to like, okay, let me get some data, let me get some results to then make a decision of something from a month ago.
Right. So with machine learning, you are never kind of done, right? Always.
Yeah,
Yeah.
and like that's one of the parts that's like very interesting to me and
Mm-hmm.
why I came to this field. Is like you're never done, but you also cannot just keeping like, your attention on everything at the same time. So like, how do you decide when it's good enough that you should focus on something else, but you always have that on the back of your mind, like something's gonna happen? Because one of the most critical things when it comes to machine learning being very different from software engineering is On software engineering, you have a bug, you
Hmm.
like get file a ticket, someone creates a regression test, fix that, it's never a bug again. Now a machine learning model, you train it, and you're like, okay, it has detected all these cases. Maybe a week later, it's not going to detect those cases anymore because the data has changed, your training procedure has changed. So back at the NVIDIA, we used to have a problem of like, can I file a ticket to detect red trucks? You know, like, sure, but like that's a hard problem to solve to ensure that we will always detect those cases.
Hmm.
Yeah. Imagine even in the furniture industry, it's similar as like, I want to find all of the armchairs that are upholstered or whatever. And then in different settings, it's different.
Right. And I mean, the example COVID happened, like a lot of behaviors change, patterns change, and how do we incorporate that? So that it's again, it's not a very concrete, well-defined problem. Yeah.
Makes sense. Um, in terms of teams, as we're talking about Agile, what team structures have you found to be most effective? Meenakshi, you had mentioned the data team, the data science team. There's others who are building applications. So, in building AI products, is there a team structure or pod structure? I don't know, that has worked really well for your respective orgs.
Hmm. Um, so I'll give a very overarching view, and then I'll give details more about how my team is structured. So within Wayfair, data science teams are aligned with the verticals, different business verticals like marketing, operations, and so there's a tighter because data scientists, they also work with data analysts and get business user requirements basically. Um, and some of them then have ML engineering support along with that. And then there are other core infrastructure teams, for example, data platforms, and other platforms and security, cloud infrastructure. There are different teams that are organized. Our team primarily has software engineers, architects, MLOps engineers, and then we have product management, working closely with them hand in hand. um, the ratio that we have is, as of now, is 4:1, so 4 developers and 1 product manager. Our teams are aligned with ML phases. So we have features and data, build and train, and deploy and monitor. And each of these teams focus specifically on tools developing for that stages. Of course, we also work on how to integrate well these products. But so far, that has been the design that has been working well for us.
Got it. Got it. And then you build the platform, and the verticalized teams then leverage the same platform across the different
Right,
areas.
right. So we release these platforms, and all the data scientists from respective teams, they use it for model development, training, and deployment, batch versus real time.
Got it. Got it. Awesome. And compared to data science, like other kinds of teams, just software engineering, is there anything special you found here, the way that you have had to architect the team on your side?
Right. I think one distinctive feature is aligning ourselves for ML phases. I think I haven't
Hmm.
seen that
Got
in
it.
my other teams because we were all integrated into uh, one tool or suite of tools, and then we wore different hats, which is some software
Hmm.
engineers, quality engineers, and so that was a different structure than machine learning.
Interesting.
Yeah.
Got it. Got it. That is fascinating. Lucas, how are you guys structured?
Yeah, we are not that big a team. We have just one vertical for our product, I would say. But when I joined Virufy, we started having more data scientists. But as we evolve, we find out that we need to do something with the model. We need to productionalize it. We need to test it. So we brought up more machine learning engineers, which is kind of also new naming for data scientists with kind of software background. So we're trying to hire more machine learning engineers to be able to help us to bring the model to production and test it out, and at the end also operationalize. So bring it to the, I'm sorry, make it work. So yeah, so that's why we're also building a third team, which is MLOps. So it's kind of combination of operational team and the machine learning engineers to know what this model is doing and to be able to deploy it, and then at the end monitor, like Meenakshi mentioned that they have this last stage, which is very crucial for the business to see the value if this model is delivering what it needs to do, check the accuracy daily, or have a monitor pop-up alarm there's some issues. And yeah, so this is the third team, which is very important. And since we are dealing with more with audio files, we have also audio engineering with machine learning background. So those are our 3.5 main areas.
Interesting. It's interesting that you separated ML engineering from ML ops. So folks use these terms very interchangeably. For you guys, what was ML engineering versus ML ops? Like, what was the difference there?
Yeah, ML, the machine learning engineer, then they would create a model and kind of train and do all these machine learning related tasks, while the MLOps has still the knowledge about the machine learning, but it's more concentrated about the operational aspect of the model.
Got
So
it.
they
Got
work
it.
close to each other. We try to remove all these silos between those two teams, because usually the machine learning engineer, or prior it was data scientist, didn't have much knowledge about the IT stuff. It was more about data analyzing and just doing their work, and then there was no like versioning the code or creating CI/CD pipeline. Conrado you explained before, so that's why we are trying to merge them together.
Got it. Got it. And Conrado, any sort of prototypical team structures from NVIDIA or Twitter you can share?
Yeah. The way that I have seen this kind of things work well is first, Lucas, what you did in your orgs, right? Like start with some data scientists, realize that you need more machinery, and then realize that you need a sub team very specialized for the operations. Data scientists, because developing models is something that's very domain specific, and you need to understand the problem. Treating data scientists as like exchangeable, it's not a good strategy for teams. So you should have your data scientists really focus on the particular kind of problem they're trying to solve. Of course, as they want to move inside the company, you should let them. It's going to benefit you, but you should really make sure that they are focusing on a type of problem first and leveraging that knowledge that they are only going to get by executing. There is the old saying, there is no compression algorithm for experience. You need to actually get it running. But when it comes to supporting them, the separation between the stages is usually the one that gives the highest benefit. The same way that in software engineering we separate, there is like a backend engineer, there is going to be an ops engineer, there's going to be an SRE, there is going to be a front end, because all those different areas are important for the product, but they're still different enough that you need people with different focuses. So when it comes to building the infrastructure, having a team that focuses on pre-training, like data preparation, a team that focuses on training, a team that focuses on bringing that model into production, they will have different KPIs for how well they're doing. And trying to mix them together is going to end up with a hybrid that doesn't do like neither of these okay, but you're still going to have a huge team that now you need to figure out what to do. And usually you're going to end up splitting them.
That makes sense. So it looks like data science gave them domain specific on the infrastructure side, someone focused on the training, and then also separately in operationalization seems to be working quite well. Both Lukas and Meenakshi, you guys spoke about building capabilities, automation, all of that. So one question that I think the community is generally struggling to figure out is, how much standardization, how much automation. In your cases, what benefits have standardization or automation brought to your teams?
Yeah, I can. So I'll start with standardization, I'll just share some examples of what we have seen in certain areas. And standardization is a broader term. So if you look at standardization of tools, our teams, data science teams, we until last year, we had a lot of setup in on-premise machines, and the way we grew, a lot of bespoke solutions were out there. So as we moved to the cloud infrastructure, we know as an ML platforms team, we unlocked few capabilities, and that gave us standard set of tools, which means less bespoke solutions, streamlined documentation, training, um, and debugging, right? Because we now know what workflows are supported and what's not. If you think of standardization in softwares, while we are integrating different pieces together, um, we release software libraries and APIs, and that allows us, again, better user experience in that sense. And finally, standardization in terms of process. Like, I think the last one was more like software standardization. We standardized the way we tagged the compute, the resources, and now we have, which led paved path for automation. So now we have better product tracking and reports. So I think those are some interpretations I have for standardization and examples. In terms of automation, one thing that comes to my mind is um, compared to on-premise, where we would have a big ad hoc manual process to get access to resources, especially GPU resources. Now we have more provisioning, which is more self-service, more flexible. And that comes, a lot of it is obviously cloud powered, but that definitely speeds up the development for our data scientists.
Got it. Got it. Lukas, in your case, your talk was on automation, so I'm assuming this has been used pretty widely at your team.
Yeah, it allows the data science team just simply move faster over small POCs and create them over easy with small parameters and iterate over and over much faster. Whereas on the beginning, you might start with manual process, of course, because it's the most known, or that's you know what to do. But once you need to do like multiple models, multiple iteration over multiple different features, then you need to create an automation process. So that's there are multiple tools who can help also in the cloud, but we kind of went more an open source route where we pull from internet. There are multiple documentations from open source, and this helped us to train automatically the model and change the parameters on the fly. So the automation was pretty much a big key in our team, which speed up the process.
Got it. And it looks like you took it all the way to CI/CD. Is that right? For model delivery as well.
Right.
Got it.
So
Got it.
once there's a small change, the model gets retrained and then deploys to an either inference, so live inference, or the batch processing. It depends on that.
Got it. Got it. Awesome. Conrado, anything else you want to add to that? You worked on both systems, so you might have a lot to say.
I think the challenge of dealing with machine learning for a lot of these questions is machine learning is a very, very long tail of applications where as you go farther along, they're very different from each other. But you also don't want to let your data scientists do everything by themselves because that's not what they should be doing. That's not where they should be spending the time. Every time that I think about a data scientist spinning up EC2 instance themselves, I'm like, why are you doing this? Like, you should not be doing this. And that balance between giving the data scientists all the flexibility that they're going to need for their application and also saving their time, like on things that they should not be doing, it is usually a hard balance. So usually what works well from what I've seen is it starts with the teams running and doing whatever they need to do to deliver value and start to observe what are the patterns that come up. and what are the things that you as an organization seem to have in common, and start extracting those and supporting them, so that now those teams have lower waste in terms of like human resource, and now other teams can start thinking, oh, okay, like there is already this, can I adapt what is running on top of that? But assuming that you're gonna build a silver bullet for all possible cases, it's gonna take you a while to get there. And don't let the fact that it's not a silver bullet stop you. As long as you're making progress on your team and automating the things that you can automate, you should be good.
That makes sense. Um, so we've talked about the ML lifecycle a bit, the ETL, and it looks like the Wayfair team is also structured in that manner. The ETL data prep, model training, then there's operationalization, monitoring. In your respective experiences, what has been the most challenging part of this, and how has that changed over time? Because we've also seen cases where something was the hardest problem over time, it changed to something else, and it went back to something. So if you can highlight what have been the challenges, that'd be an interesting perspective.
Yeah, I can quickly touch base because it's still kind of in progress. So definitely the training to make sure that these tools will be provided as MLOps engineers are available to data scientists. So the training to kind of go from simple SQL statements and doing all these to elaborate other tools as well, where we set up those tools for them. So the knowledge transfer and teaching them to use them, that was pretty challenging because not everybody has the same background and not everybody's the same page. So I think that was the biggest kind of change for us.
Got it.
And since we moved also to a cloud, before the data scientist was using just the Jupyter notebook, whereas on a cloud you have much broader spectrum of services you can connect together and work to make your work easier.
Yeah. So I can maybe highlight two issues. I often hear data scientists, you know, complain about the access to resources. Like the big data is a big problem. It's millions of rows, especially in the e-commerce where the domain we are, and data keeps growing, and we have to look back historical data, sometimes a year. There's a wider range, so millions of rows, terabytes of information, and then these deep learning models you have to train, like Lukas pointed to that, you have to train several times. And it's very interesting. There's this data scientists say, hey, if I can subsample, or I can undersample, but then that impacts my performance. And so there's this question, I need so many gigabytes of RAM. And so there's this interesting question of what is the guidance on optimization. So there are several problems or solutions or approaches to handle this, but I think big data and data pre-processing and training on big data is first challenge. Yeah, and I think I'll also touch on reproducibility a bit. Again, coming back, this is different than software engineering because we have data aspect, and hence reproducibility becomes even more challenging because now you have to know what was the data that I used to train it, and it's so you need model, you need data, and the parameters or the configurations. So together they give you the reproducible artifact. So I think that's also a very challenging part of data science.
Makes sense. I worked on Model DB, and that's what we did. So yes, I'm with you right there. Conrado, you want to add anything else to that?
Yeah. I read one on each side of the spectrum about like resource and like figuring out among like this petabytes of data, which one matters, and how do you get the data scientists to use those resources? Because if you let them go free, they're going to use way more resource than you can actually afford. So how do you balance that out on like which efforts should get how much amount of resource? Because it's kind of a guessing game. You don't know which ones are going to be the most impactful beforehand. So trying to manage those resources both from an availability perspective and a cost perspective can be pretty tricky when you're asking people to like go through a lot of data to figure out if something might be interesting and make an impact. So like if you get your model to 10 times the amount of data, is the gain that you gain on the model worth the amount of money that you actually spend training that model? Maybe it is, maybe it's not. How do you make that call? And on the other side of the spectrum, a very interesting problem that we used to have at Twitter is data science is very intuitive to an extent of like what you think makes sense. Whenever we build a model and we're certain that model is going to be like better than the one in production, and the model performed like much poorly, and we had no idea why. Like it's the kind of stuff that's like it is obvious that should be better. Like it has more features, it has like more created stuff. All the offline tests shows that it's better, but when you put it on your A/B test, it performs worse. And now you don't know why that happens. So like understanding that model and like being able to go back and say, okay, something in between here doesn't make sense. What's going on? And like, why did you spend all this time on this model that didn't actually work? Like, did you have a problem on packaging the model and deploying it? The model itself is actually okay. It's just a software problem. So there is a lot of different pieces that glue together. And when you need to answer a question, to her point of traceability, if you're not tracing what you're doing, you just don't know where to look for and start bisecting.
Makes sense. So you would pick the resource utilization and then model understanding or debugging.
Yeah.
Two of the highlights. Makes sense. Makes sense. Awesome. So we're almost at the end of the panel. Let me wrap up with one final question, which is if you were to share the top two things with the audience on things they can do to accelerate the development of AI products, what would they be?
I think I can get started. It's easy. I think I've already alluded to moving to cloud, and it's for several reasons. Some of the inherent capabilities of cloud help you with speed and scalability, which we are still, we are leveraging, we are exploring. And the second one is focusing on user experience. So we continue to develop easy, simple user interfaces. We don't want our data scientists submitting Terraform code, and so like I think so those were two biggest investments and returns where we saw in the past few quarters.
Yes, no one should have to write Terraform. Well, not no one. Most people shouldn't have to write Terraform. Agreed. Lukas, what would you say?
Yeah, definitely Terraform can be pain sometimes. And nowadays you have also drop down, you just put graphical interfaces together and you have infrastructure as a code. Yeah, definitely the future looks different. For us, it's the data delivery. Since we are data driven, we need to get more coughs to have better predictions and collect all these coughs across the globe. We had to expand the data sources. So we didn't just concentrate on one market, but we had to expand. So definitely the data, investing in the data delivery is I think biggest topic too. And then of course the cloud definitely help us to increase our productivity and deliverability of the AI product.
Yeah. And I just agree with it. The problem that a lot of teams don't understand when it comes to machine learning is even though your problem might be well defined of I need to increase revenue, I need to increase click-through rate. When you define the problem for a software engineer, they can go and start like writing the codes to do that. because like you instruct them, okay, we need to change the color of this thing, we need to change this button, we need to change this UI. When you define the problem for the data scientists, they still need to go through their discovery process. They still need to go through the data, understand what they can use across that. They need to go through the literature and see what things they can explore. So the same discovery that we do on like product about thinking how people are going to use it, they need to figure out, they need to do the discovery on the data to figure out how they're going to use the data. So the way to do that is leverage the cloud. There is no way that you're going to always have the capabilities on premise because it's very bursty. Sometimes you're going to need like 1,000 machines for an hour. And then you're going to spend the next 2 days analyzing those results and understanding. So leveraging those powers of the cloud and like really embracing that you need to have a burst that you're not going to be able to sustain in an on-premise environment. And then letting those data scientists do the discovery work. That's just not coding, it's just not typing into an ID, but really understanding what is the problem and what tools I have to solve the problem. Those are usually the two biggest challenges that I've seen coming to these teams.
Got
and
it.
please no Terraform for that.
So cloud seems to be common user experience, data gathering, and also giving room for exploration by the data scientists before they can jump in. Wonderful. With that, we're at time. Thank you so much for joining us for the panel. And thank you to Meenakshi and Lukas for your previous talks as well. This was really fun. And we'll be taking questions on Slack now. So appreciate everyone's time. We'll see y'all later.
Thanks,
Thank you
folks.
for having us. Yeah.
Thanks so much.